Hello, statistics. We're going to start with, chapter one from the sixth edition that we're supposed to have. But if you picked up a statistics book from Bevel West, it will be the fourth edition. And those of you who are from Bevel East and doing AP statistics, we're still going to be learning the same material. We're going to use the PowerPoints as a guide, and I will make sure that I upload worksheets to go along with what we talk about. Here's the intro. What we're going to do in chapter one is lots of vocabulary. So the overview, data classification, experimental design, lots of vocab. Did I mention that? All right. The keywords here: population, sample, parameter, statistic, descriptive statistics versus inferential statistics. Data. We hear it all the time. It's any info coming from observations, counts, measurements, responses. They can be in many forms. I wonder if I can. Oh! I can move my face around! That's so cool. All right, so anyway, it can look in various different manners as long as it has, well, some sort of number or response from numbers. Okay, so statistics, let me move my face again. Definition: science of collecting, organizing, analyzing, interpreting data in order to make decisions, because everything is based off of statistics, especially since it's a political year. You're going to hear tons of numbers and percentages being thrown out that this is why I believe bleh. Shoot, we've been hearing it with COVID-19. This is why we make these decisions of whether we're going to be remote learning or not. All right, so you might want to write this down just to get it into your head. Population is everything possible that if I could survey every person in the United States, that's a population. However, a sample would be a few people from the United States. Pause the video, write down verbatim, word for word, what we see here. All right, so this example, in a recent survey, 1,500 adults in the United States were asked if they thought there was solid evidence for global warming. By the way, this is already outdated. It's from 2009. But 855 people of the adults said yes. Identified population, sample, describe the data set. So, population, everybody in the United States. And we see the solution. Sample is the 1,500 that we specifically surveyed. And just recall that the sample is a subset of the population. As we go throughout this school year, we're going to be dealing with samples. But we have to realize that we want to get these samples as close to representing the population as possible. And the data set consists of the numbers. So the 855 yeses, and realizing, oh, if I take 1,500 minus 855, I get 645. Parameter is the population characteristic. The statistic comes from the sample. So notice the alliteration we have underlined here. Parameter, population, statistic, sample. So most of the statistics we hear are actually from samples because it's very rare you can get everybody in the state of Illinois tested for COVID. It's impossible. All right. Next example, distinguishing the difference between parameter and statistic. Are we looking at a population or a sample? So, first example, a recent survey of a sample of college career centers reported that the average starting salary for petroleum engineering majors is $83,121. Realize that this is outdated, but do we think that it's going to be population or a sample? Pause the video, think for yourself, go back to the definitions, and take a guess before I go to the next slide. So it is a sample statistic because it's based on just a subset of all of the petroleum engineering majors. Notice how it actually says the word sample, so keyword. If it says sample, it's a sample statistic. All right, the 2,182 students who accepted admission offers to Northwestern University in 2009 have an average SAT score of 1,442. So pause, take a guess. Here's the answer. Population parameter, let me move my face. There we go. The SAT score is based on all of the students who accepted the admission. So that was like, they didn't survey anybody else. They got them all. All right. So branches of statistics here either, so this is branches of samples that we can get. We could either get descriptive with the actual numbers, or inferential, sort of like after the numbers. What are you going to conclude? So, how do I move my face? All right. So typically we get descriptive statistics first, and then inferential, trying to get more and more statistics about the same population, meaning like get more and more samples from this population to try to make an inference about the entire population. All right, moving my face all day. So let's see the difference between descriptive and inferential statistics. You can pause and read it, or I'm just going to read it out loud. Decide which part of the study represents the descriptive branch of statistics. What conclusions might be drawn using inferential statistics? So a large sample of men aged 48 was studied for 18 years. For unmarried men, approximately 70% were alive at age 65. For married men, 90% were alive at age 65. Out of this, anything that deals with a number, basically descriptive. But then what's the inference that you want to come from it? Like, if you want to live forever, you might want to be, I don't know, I guess married. That's some sort of conclusion. But so if you want an actual set answer, descriptive statistics involve statements with the numbers. Possible inference is if you get married, probably going to have a longer life if you're a man. All right, so this is all we have currently, just lots of vocab words. Check Khan Academy for your first assignment to see whether or not you understand the difference between population, sample, parameter, statistic.